Okay, this is video assignment number 1 for chapter 13. And the question is, the equilibrium constant Kc for the reaction A plus B equals AB is 3.0 at our temperature. Consider the volume to be 1. Does the situation depicted in the figure below correspond to equilibrium? If not, in which direction will the reaction proceed in order to attain equilibrium? And so basically we are given a box. I'll try to just explain it. There's red and blue molecules. Red is A, blue is B, and then some of them, red and blue, are together, which is the A and B molecule. And then here is my work. So here I have what we are given. This is the balanced equation. A plus B is AB. And then we have Kc, which we already know equals 3. This is just the equation that we can get to solve for Kc, but we already have it, so we'll get to that later. Basically, you put the products on top, the reactants on the bottom. And the volume that we have is 1, which I have written right there. And so the answer that we are asked to, first we need to figure out if the figure corresponds to the equilibrium. So in order to do that, we actually need to count the amount of blue, red, and so basically we need to count the amount of A, B, and AB. Reminder, A is red, B is blue, AB is red and blue together. So I went ahead and counted all of them. There's 18 A molecules in the figure. There's 24 B molecules in the figure, and there's 10 AB molecules in the figure. So now that we have these, we can actually plug this into here. And what we're looking for is we're looking to see if this number, once plugged into here, is equal to 3. If it's equal to 3, then that means it is equal to equilibrium, and it's at equilibrium. So I went ahead and plugged those numbers in here. That ends up being 10 divided by 18 times 24. And the number we get is 0.023, which, as we can tell, is significantly smaller than 3. So we are not at equilibrium. Now, because we are not at equilibrium, we have one more question to answer. And the question is, if we're not at equilibrium, in which direction will the reaction proceed in order to attain equilibrium? So a way that I like to think about this is based on the number here, obviously, so if we know the products go on top and the reactants go on bottom, if we can just, simple math, we can tell that 18 times 24 is going to be significantly greater than 10. So we know, just based off of those simple numbers, that we have a lot more reactants. So we have a lot more stuff on this side of the equation than we have on this side of the equation, right? But in order to reach equilibrium, we want it to be more balanced. Instead of, hanging very heavily on this side, we want it to be more balanced. So in order to do that, the reaction is going to shift right, which means we're now going to try to make more AB molecules. So it'll reach equilibrium. So the reaction is going to actually shift to the right because of that, if that makes sense. Another way to think about it, and just like a simpler way, I guess, if you kind of are confused. So QC is what we can find that if QC is equal to KC, equilibrium is met, like I said before. If QC is less than KC, that means that we have a lot more reactants, which means we need more products, which means the reaction is going to shift to the right because the products are on the right side of the equation. If QC happened to be greater than the equilibrium, that means we have a lot more products. Therefore, their equation will go to the left. Specifically in this problem, like I said before, the reaction will shift to the right because we do have more reactants. So that's telling us that in order to reach equilibrium, we need more products.